Hello everyone. Welcome back to the course of data structures using C language. This video is brought to you by Newton's Group of Institutions, Macharla. This is Aravind Yegireddy from the Department of Computer Science and Engineering. Today, we will discuss how to reverse all the elements of a single linked list, how to swap two nodes in a single linked list, and sorting data in the single linked list. To reverse the elements in the linked list, let us use the logic of reversing the elements of an array. Let us now consider an array consisting of 6 elements, say like this, with values 10, 20, 30, 40, 50, and 60. Now, how do we swap? We can swap the first element with the last element. For that, we need to consider two variables with I is equal to 0 and j is equal to number of elements minus 1. So here, in this case, j is 6 minus 1, which is 5. Now, how to swap? While on some condition, so let us see what is that condition in the later stages. And with the help of the temporary variable temp, we need to swap. So into temp, we need to store the a of I value. So here, I value is 0. So a of 0 is 10. 10 value is stored into the temp. And a of I, into a of I, we need to store the a of j value. And into a of j, we need to store that temp value. So here a of j is 50 we are storing into this place, and 10 value we are storing here. So now, after swapping these two, now we have to swap the second element. That is element with index 1 and with the element with index 4. So here the I value will become 1 and j value will become 4. So I value will become 1 and j value will become 4. So we have to increase the I value and decrease the j value. So here we write I plus plus j minus minus. So I value will become 1 and j value become 4. So again, here the condition, based on the condition, what it will do is it will come into this loop. So temp will become a of I. So a of I is 20 will be placed here, and the similar case. So the element 20 is stored here and the 50 here, which is being stored into this index. Then again I plus plus and j minus minus. So now my I value will become 2 and j value will become 3. So the elements of third element and the fourth element will get swapped. Now again the I value, which will become 3 and the j value will become 2. I plus plus and j minus minus, I value will become 3, j value. So the condition is false. So we come out of the loop. So here 60, 50, 40, 30, 21. So we have reversed all the elements in the single linked list by swapping here. Now, let us consider the single linked list with 5 nodes which are connected like this, where the root is pointing to the first node. Now let us see how to reverse all the elements in the single linked list by applying the logic what we have seen in the previous array case. So here first we have to swap the first node with the last node. So we have to swap this element with the this value. So how do we swap? Here we must consider two pointers, one pointing to the first node and the other pointing to the last node. So for that we will be using the structure pointer variable p and q. So p will be pointing to the first node, so this location, and q will be pointing to the last location, last node. So how we can do that? So here, to make the q control to the last node, what we have to do is we have to find out the length of the list. So now let us write the method or the function for implementing the reverse of the linked list. So void reverse linked list function. So here we declare two variables I and j of integer type and declare one more variable of length which is of integer type. Next, we need to find the length of the list by using the length function. So len is equal to length. So now the length value will become 5. So here the length value became 5 once after calling this function length function. Now we have to initialize the I value to 0 and j value to length minus 1. So I value will become 0 and j value will become length minus 1. That is 5 minus 1 is 4. So here I is 0 and j is 4. Here it is while I less than j condition, because when becomes true, we need to execute the logic. Now I is 0 and j is 4. But now I is not pointing to the 0th node and j is not pointing to the 4th node. So then what is that for we are using these I and j values? So here using this I and j, we should use two more pointer variables such that one pointer variable points to the first node and the second pointer variable points to the last node. So how? Means first we need to declare two pointer variables of type struct node pointer type. Let them be p and q. And initially these two pointer variables need to point to the root variable. So we have written p is equal to q is equal to root. So here p is equal to what is the root value? 2046. So 2046 is stored here, 2046 is stored in here. So p will be pointing to the this location first node and the q also points to the first node itself. So p is pointing to the first node and q also pointing to the first node. Now we have to move the control of the q to the last node. So we have to move the control of the q to the last node. P need to be in the same place because p has to point to the first node. So q only the control we need to move to the last node. So how we can do that? So to move the q control to the last node, we use the same while loop while I less than j. Now taking the help of another variable k variable, assigning the value k initial value 0. So here we have to do one more k loop, while loop, that is while k less than j. Here while k less than j, q is equal to q2 link, then we have to increase the k value. So let us see the logic how it is working. First initially the k value is 0. So k value is 0 and j value is 4. 0 is less than 4. So q is equal to q2 link. So what is q2 link? Q value is 2046. 20462 link is 5048. So 5048 will be placed here. Then k plus plus. So k value will become 1. So now again we come to this loop, k value less than j. 1 is less than 4. The condition is true. So again we come into this internal while loop. So q value will be q2 link. 5048 to link is 9042. So that will be stored here in the queue and the k value will become 2. Now again 2 is less than 4. The condition is true. So again we enter to this while loop, q to link 9042 to link is 7042. 7042 will be stored in q and the k value will become 3. Okay, again 3 is less than 4. The condition is true. So again we enter to this loop. Now the q to link value, that is 7052 to link is 3048. 3048 will be stored in q and the q value will be k value will become 4. Now 4 is less than 4. The condition is false. So we come out of this particular while loop. So when we have come to the last node, what we need to do? We need to swap the data. So we need to place this 50 here and 10 here. So for that, what we are doing, we are using the temporary variable. Temp is equal to P2 data. So 10, it became 10. Now this 50 we are storing here and this 10 we are storing here. So P2 data is equal to Q2 data. So the 50 will be stored at this location and the 10 will be stored at that particular location. So once after completing this, what we have to do, we have to increment the I value and decrement the j value. So once after swapping, we need to bring the p pointer to this location and q pointer to this location. So here for doing that, I am incrementing the I value, I plus plus. So my I will become 1 and j minus minus j will become 3. Now here, what I have to do, I have to bring the pointer. So already swapping is being done with the last element with the first node, last node with the first node. Now I need to swap the second node with the last but one node. So these two nodes I have to. So now the P pointer should point to this location. So how we can do? P is equal to P to link. So when I say P is equal to P to link, P will be pointing to this location. Then Q I need to bring here, but in the backward direction, which is not possible because this is not a double linked list. It is a single linked list. So what I do, I initialize the Q value to root. Q is equal to root. So now my while loop is complete. So once when the while loop is complete, I will check the condition while I is less than j or not. So 1 is less than 3. The condition is true. So when the condition became true, I need to make the k value to 0. So now my k became 0. While k less than j, 0 is less than 3. The condition is true. So now I enter to this link. So q is equal to q to link. What is q value? 2046. 2046 to link is 5048. So now 5048. So my q will be pointing to this location. Now the q, instead of pointing here, it will be pointing to 5048. Then k plus plus. K value became 1. 1 is less than 3. Condition is true. So q will be q to link 5048 to link is 9042. So here 9042, k value increments 2. Now again 2 is less than 3. The condition is true. So here the value is 7052 and k value becomes 3. 3 is less than 3. The condition is false. So it will come out of this while loop. Now temp is equal to P2 data. So what is P2 data? P2 data is 20. So 20 value will be stored in temp. And in P2 data, we are going to store Q2 data value, and Q2 data value we are storing into with the temp. So here 20 will be come here, 40 is coming here. So 50, 40, 30, 20, 10. Now again I plus plus. So what is I? I will become 2. J minus J will become 2. P is equal to P to link. So P will be pointing to this location and Q is equal to root. Now it will come to this loop. 2 is less than 2. The condition is false. So it will come out of this while loop. So now already the elements are sorted 50, 40, 30, 20, 10. So this is how we are going to reverse the elements in an single linked list. Now let us see how we can swap two elements in a single linked list. So swapping the elements in a single linked list. So here not elements, we are going to swap two nodes in a single linked list. So now let us once again consider the same single linked list with 5 nodes which are connected like this, where the root is pointing to this particular starting node. So here we are swapping two nodes which are adjacent to each other. So if I say the location is 2, I'll be swapping second node and third node. If I say the location is 4, I will swap the fourth node and fifth node. If I say the location is 1, I will swap first node and second node. So here we are swapping two adjacent nodes. So nodes itself we are swapping. So now for suppose that we have given the location as 3. So now we have to swap the third node and the fourth node. So this node is to come here and this node need to come here. So to take a point, so for this, to make this, we need to take a pointer which is pointing to the second node. So if we are swapping the third location, we need to place the pointer in the second location. So my P will be pointing to this node. So how can we make the pointer P to point to the second node? Again, the same logic. Take the initial I value 1, P is equal to root. So the P will be pointing to the root. So here the P value will be pointing to the root. Now while I less than location minus 1, that is 1 is less than location 3 minus 1, 2, condition is true. So what I will be doing, P value I will be placing with P to link value. So here P is equal to P to link. So my 2046 will become 5048. So that the P will be pointing to this location. Then after that I plus plus. So what will be the I value? I plus plus 1 plus plus 1 is 2. So 1 plus plus 1 value is 2. Now 2 is less than location minus 1. 2 is less than 3 minus 1. Wrong. 2 less than 2 is wrong. So we come out of this particular while loop. Now we have to take two more pointer variables Q and R, such that Q will be pointing to this node and R will be pointing to this node. Now how can I make this Q point to this node? This Q is nothing but 9042. How is it? It is P to link value. So I need to make Q is equal to P to link and R is equal to 7052 is nothing but Q to link value. So this is how I take the 3 pointer variables which will be pointing to these nodes like this. Understood? So now what we have to do? We have to swap the two nodes which are present at the location, third location and the fourth location. So to make the point, once after making the pointers pointing to these locations, now suppose to make these two, let us see how the structure will be once after swapping. So let us see the structure. So here this is my first node which will be like this. Now the second node 20 will be similar in the same place. So here the second node is like this. Now the third node. So the third node need to be come here. So this fourth node need to come here. So 407052. This need to go to the fourth location. So it is like this. And the fifth node as it is. So we are swapping the nodes. Complete nodes, not the data swapping. Here we are completely swapping the nodes. So here the address need to be changed at the link part. So here the address values need to be changed at the link part. So now what we have to do is, let us start with the connection from the right side. So let us see how we can link these two values. So here in the link part, what the value I need to have? 3048. So what is 3048? 3048 is R to link. R to link value is 3048. Now this R to link value I need to place in 9042 to link. What is 9042? 9042 is Q. So in Q to link value, I need to replace with R to link value. So that is what we have to write. So R to link is being replaced with within the assigned to Q to link. So now 3048 value will come here. Now let us see the second part, that is this one. Now here I need to place the value 9042. What is 9042? 9042 is Q value. So I have to place the Q value in 7052 to link. What is 7052 to link? 7052 to, so link is nothing but arc link. So in R link, I need to assign the Q value. So Q value I am assigning to R0, R2 link value. Now let us see the third connection, that is a left side connection, this connection. So to connect this, now here I need to place the 7052 value here. What is 7052? 7052 is nothing but R. Then what is this? 5048 link. So what is 5048? P2 link. So in P2 link, I need to replace with the R value. So this is R is equal to P2 link. So here the value becomes 7052. So by using these three statements, we can swap the single linked list. So this is the simple logic what we are going to use while swapping the elements. So these three steps we need to follow while we are doing the node swapping technique. Now let us see how to sort a single linked list. Now let us see how to sort a single linked list. So let us consider the single linked list with the 5 nodes connected like this, where the root is pointing to the first node. First, we need to consider two pointer variables, struct node pointer type. One pointer variable initially pointing to the root. So this pointer variable which points to the first node, we need to compare with each and every node in the data part in the linked list. Then whenever we find the data part with a smaller value, then we need to immediately swap it. So for example, consider this single linked list. First pointer variable P is pointing here, pointing to the first node, and the Q is pointing to the next node immediately after P. Then we need to compare the P data with the Q data. So we need to compare the P data with the Q data. If P data is greater than Q data, then what we need to do? Immediately we need to swap the data. So here in this case, P data is greater than Q data. So what we have to do? We have to swap the data. So once after swapping, it will be like this. So 25 will come here and 100 will come this way. So once after swapping, what we need to do? We need to increment the Q value. So Q is equal to Q to link. Q need to move in forward direction until the Q value becomes a Q to link value becomes a null value. We need to forward. So here the Q will be pointing to this node. Now this first node data, that is 25, is compared. 25 is greater than 57. No. So no swapping is required. So we move the pointer to this location. Now 25 P2 data is compared with Q2 data. 25 is greater than 18. Yes, the condition is true. So we need to do swapping. So once after swapping, 18 will come here and 25 will be pointing here. Then once after swapping, we need to move the Q pointer to the next node. So Q will be pointing to this node. Now 18 is greater than 27. No, the condition is not true. So no need of swapping. So we need to move the Q pointer to the next location, that is Q2 link. So Q2 link will be null. So the Q value will have null. Once when the Q value is null, our first iteration is complete. Now we need to go for the second iteration. So in the first iteration, if you can notice that once after completing the first iteration, the first smallest value will be in the first node. So 18 is the smallest of all these, that after completion of the first iteration, 18 will come to the first node. Now whenever we start with the second iteration, what we have to do? We have to increment the P value. So here the P will be pointing to the second node. So whenever we start the second iteration, when the P points to the P control moves one forward, immediately we need to place Q pointing to the next location of P. Now 100 is greater than 57. So we are comparing P2 data value with the Q2 data value. So 100 is greater than 57. The condition is true. So what we need to do when the condition becomes true, we need to swap. So swapping is being done. So 57 came here, 100 came here. Once after swapping, we need to change the Q position to this location. So Q will come here. 57 is greater than 25. Again, the condition became true. So again, we have to do swapping. So 25 came here, 57 came here. Now, once after swapping, we need to move the Q cursor. So Q will be pointing here. 25 greater than 27, the condition is false. So no swapping. So once after checking the condition, if the condition is false, we need to move the cursor to the null. So when Q value becomes null, then the second iteration is complete. So after completing the second iteration, the second smallest value came into the second node. If you can notice, this is the second smallest value. So once after completing the iteration, what we need to do? We need to move the cursor Q pointer to P pointer to this location. So P will be pointing to this location. So when we come to the second iteration, immediately the Q need to point to this location. Now 100 is compared with 57, 100 is greater than 57. So swapping need to happen. So the node will be like this, swap like this. Okay, so the data is stored, swap like this. So here 57 and 100, now once after swapping, Q pointer will be moving to this location. So here 57 is greater than 27, condition is true. So 27 need to come here and 57 need to go to the last node. So here it will be something like this. Once after swapping, again the cursor need to go to this location. Q value became null. So the third iteration is complete. The meaning is third iteration is complete. So after completing the third iteration, third smallest value is in the third node. So after that, we need to move the cursor pointer to this location. And Q pointer need to point to this location. So 100 greater than 57. Yes, the condition is true. So what we have to do? We have to bring 57 here and 100 to this location. Swapping. So once after swapping, what we have to do? We have to move the Q pointer to the next location. So now my Q pointer will become null value. So when Q is null, our fourth iteration is complete. So after the fourth iteration, we have stored 57. Fourth highest value is in the fourth node. Now the P value need to move to this location. So P will, so we need to execute this condition until the P pointer P to link value not equal to null. But here the P to link value is null. So the sorting of this particular linked list is complete. So here let us try to write the logic. So here we are writing the logic for sorting the elements in the linked list. So here void sorting the linked list. Now here we are considering two pointer variables P and Q. P we are initializing it to root. So P is pointing to root. So here we are taking one more temporary variable and we are initializing the root value to P. So while condition we are going to check while P to link is not equal to null. So when P to link value is equal to null, then we need to come out of the program. Sorting is getting completed. So until the P to link value not equal to null, we need to sort the elements. So when P to link not equal to null, what we need, where we need to place the Q pointer should be next to P. So Q is equal to P to link. So P to link value we need to assign into Q value. So they are adjacent. Now what we need to do? If the Q to link value is not equal to null, then we need to compare. So while Q to link not equal to null, If the Q2 link value is not equal to null, then we need to compare the P2 data value with the Q2 data value. So if the P2 data value is greater than Q2 data value, if the condition becomes true, then swapping has to take place. So how we swap? Using this temporary variable, we swap. So into temp, we will send P2 data, and into P2 data, we will be sending the Q2 data, and into Q2 data, we will be storing the temp value. So this is how, if the condition gets satisfied, we are swapping. So once if the condition is completed, what we are doing? We are making Q is equal to Q2 link. Even if the condition is not true also, we are incrementing the Q value, Q2 link, until the Q2 link value becomes null. So once when the Q2 link value becomes null, then we are checking this condition until we are incrementing the P2 link value. So P2 link value. So until the P2 link value not equal to null, we need to execute this while loop. So this is the program or the logic what we are going to use for sorting the elements in a linked list. Thank you everyone. If you like this video, please subscribe to my channel and please press the bell icon for the latest notifications. Thank you one and all.